Hello and welcome to round 4 of your logic lessons. It's time for us to tackle that tricky or those tricky ors, or the disjunctions as they're better known. So today you're going to be writing and interpreting tables and statements of disjunction. And these, remember, are inclusive disjunctions, the inclusive or the exclusive disjunctions, the exclusive or. So I'd like you to write a compound statement now, made up of two simple statements, P and Q, and I'd like you to use an or in the middle. And then I'd like you to think, do you want your statement to be inclusive or exclusive? Can you show this using words? It might be that your statement can only be exclusive, but it's very rare that that actually happens. How, if you want it to be exclusive, can you show it in words? And then can you write it in symbol form? Have a look at the table in red to see how to write the inclusive or the exclusive disjunctions. Pause the video now and try and make up your compound statement. Okay, so you should have made up your compound statement, and if you wanted it to be exclusive, there's very few occasions when statements are inherently exclusive. A lot of the time you can have both things happen. So if you wanted your statement to be exclusive, the best thing to do is write but not both at the end of your sentence. So for example, you can have tea or coffee but not both. When you come to writing it in symbol form, and for some reason my computer has changed the symbol in the middle to be absolutely tiny, but you get the idea, it should be P and then the little downwards arrow and Q for inclusive. Exclusive has the little downward arrow, but with a line underneath it. Okay, so let's have a look at what these disjunctions actually tell us. So if you're using the inclusive disjunction, or you think you've got an inclusive disjunction in front of you, then the compound of your two simple statements can be true as long as at least one of the statements is true. It's the same as a union in set theory. So if we have a look at this Venn diagram here, you could have something that is just in P. So just makes P true. You could have something that is just in Q, or you could have something that fits in both. But wherever that element sits, it makes the disjunction of P and Q correct. So for example, this is IB Maths Studies, or there are 12 people in our maths class. So this statement is true, this inclusive disjunction is true, simply because it is IB Maths Studies. There aren't 12 people in our class, but it's true because of that IB Maths Studies statement. So if this was P, this is IB Maths Studies, and this was Q, there are 12 people in our maths class, then this statement would sit here, because only P is correct. So you can also write an inclusive disjunction in a truth table to work out when P and Q, the inclusive disjunction between them would be true. So let's have a look. If P is true and Q is true, then the inclusive disjunction between P and Q is also true, because we're saying that both of these statements are correct, and that's this area here, both of them correct. If P is true and Q is false, then the inclusive disjunction of P and Q is still correct, because one of the statements is true, and we're saying either or. So it's still correct, because that would sit in this area here. If P is false but Q is true, then the inclusive disjunction between P and Q is still true, because that's this area here. We've still got one statement correct. But if both P and Q are false, then the inclusive disjunction between them must be false, because that would be the outside area here. We're saying that neither statement is true, and so you can't say P is true or Q is true, because neither of them are. So those are the inclusive disjunctions. Now we've got some examples of exclusive disjunctions. In this case, for the compound statement to be true, it must be that either one simple statement is true or the other one is. It cannot be both at the same time. So consider this compound statement. The penalty for those found guilty is life imprisonment or death. Why can't this be inclusive? Well, clearly this can't be inclusive, because if death is one of the penalties, you can't have death and then be imprisoned for life, because you're already dead. You can't be put on life imprisonment, because that's supposed to last forever, and be put to death. They can't happen at the same time. So in this case, if this was life imprisonment and this was death, the bit in the middle could not be true. So normally, to clarify this, we would add but not both at the end of the disjunction. Looking at an exclusive disjunction truth table then, if P is true and Q is true, then the exclusive disjunction between P and Q must be false, because we know we can't have both of them true at the same time. That's this middle section here. If P is true but Q is false, then that's fine. That exclusive disjunction is correct, it's true. Likewise, if P is false but Q is true, fantastic. But if they're both false, then the exclusive disjunction between P and Q cannot be correct, because we need one of those statements to be true for the exclusive disjunction to be true. Okay, there's quite a range of questions here, and I want you to be able to try all of them. So I want you to try exercise 9E in the textbook, but only questions 1, 2, 6 and 7. They're quite long ones. Give them a go and we'll go through the answers together.